All right, sixth grade, here we go. Lesson 2.2, dividing fractions now. Yesterday was multiplying fractions. Today and tomorrow are going to be about dividing fractions and mixed numbers. So once again, I'm going to want you to take a screenshot or write this down. We'll be getting this in your notes, but this is key. Steps of dividing fractions. So at some point while I'm talking, pause it, take a screenshot, do something. Steps of dividing fractions. Step 1, make everything a fraction. Step 2, make the reciprocal of the divisor. Step 3, make the division sign a multiplication sign. Step 4, cross-check. Step 5, multiply. Step 6, simplify. Let's say those one more time. Steps of dividing fractions. Number 1, make everything a fraction. Number 2, make the reciprocal of the divisor. Number 3, make the division sign a multiplication sign. Number 4, cross-check. 5, multiply. 6, simplify. All right, we'll be chanting that. I'm going to want you to be able to say that in your sleep and be, walking the halls, muttering that to yourself. I want you to know the steps of dividing fractions. So let's actually take these steps and put them into practice. All right. 3 over 7 divided by 2. Now, once again, it's make everything a fraction. Now, 3 over 7 is already a fraction. So it's going to become divided by 2. Remember what we did yesterday. To make a whole number a fraction, it becomes over 1. So 2 over 1. Then it says to make the division sign a multiplication sign. So I'm just going to rewrite this. And when we divide, really all we're doing, since division and multiplication are opposite of each other, or what we call inverse operations, really all we're doing, instead of dividing by 2, we are really multiplying by 1 over 2. That's making the reciprocal, making the division sign a multiplication sign. So notice what happened. The first fraction stayed the same. The division sign became a multiplication sign. The 2 over 1 got flipped to a 1 over 2. That's making the reciprocal of the number turn the division sign into a multiplication sign. Now I'm going to cross-check like I did yesterday. There's no number besides 1 that can go into both 1 and 7. There is no number besides 1 that can go into both 2 and 3. Sometimes you can't cross-check. It just depends on the numbers. Now I go ahead and multiply. Well, 3 times 1 is equal to 3. 7 times 2 is equal to 14. And I can be confident, since I could not cross-check, that this is in simplest form. It is not an improper fraction. 3 is smaller than 14. And thinking about simplifying it, there is no number besides 1 that can go into both 3 and 14. So I am confident that I have the right answer here. Moving along to number 2, 5 over 6 divided by 2 over 7. So this is how I like to think about it. The first fraction, 5 over 6, stays the same. Everything's already a fraction, so there's nothing to change. No whole numbers to turn into fractions. No mixed numbers to turn into fractions. First fraction, 5 over 6, stays the same. The division sign becomes a multiplication sign. I make the reciprocal of the divisor. The divisor is the number I'm dividing by. And in this case, I'm dividing by 2 over 7. The reciprocal of 2 over 7, if I flip it, the inverse number is 7 over 2. When I go to think about cross-checking, there's no number besides 1 that can go into both 2 and 5. There's no number besides 1 that can go into both 6 and 7. There are numbers that can go into 6, like 2 and 3, but none of those can go into 7. So I'm ready just to go ahead and multiply. Well, when I multiply my numerators, 5 times 7 is 35. When I multiply my denominators, 6 times 2, well, 6 times 2 is 12. And then I'm thinking, okay, here is now I have an improper fraction because 35, my numerator, is bigger than my denominator 12. So I need to actually do 35 divided by 12. I need to do the division problem that the fraction gives me. Well, when I think about my multiplication by 12, I can think, well, 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 36 is bigger than 35, so that tells me that 12 can only go into 35 2 times, and I know that that's 24. So then when I think, well, if I were to take 24 away from 35, 5 minus 4 is 1, 3 minus 2 is 1, I see that there are 11 left over. So my numerator is going to be 11. My denominator here is 12, so my denominator here is 12. I could not cross-check, and sure enough, there is no number besides 1 that can go into both 11 and 12. I end up as a final answer, 2 and 11/12. All right, 2 more. I just don't think it's that difficult what we're doing today, 6th grade, so this isn't going to be a real long video. Once again, we have 2 fractions. The first fraction, 4/9, is going to stay the same. So that's going to become 4/9. What happens to my division sign? You remember. It becomes a multiplication sign. I look at my divisor, 3/5. I'm going to flip that, and it's going to become 5/3. Now I'm ready to go ahead and cross-check. So I'm thinking about cross-checking. Is there a number besides 1 that can go into both 9 and 5? No, there isn't. Is there a number besides 1 that can go into both 4 and 3? No, there isn't. So I'm ready to go ahead and multiply. I'm going to go ahead and put my equal sign there. Well, 4 times 5, I know that that is 20. 9 times 3, I know that that is 27. Since I couldn't cross-check, I can be confident that that's in simplest form. And sure enough, there's no number besides 1 that can go into both 20 and 27. I can think of several numbers that can evenly go into 20. I can think of several different numbers that can evenly go into 27. But the only number that can go into both 20 and 27 is 1. So this indeed is in simplest form. All right, last one, 6th grade. 12/25 divided by 4. So once again, my first fraction, 12/25, is going to stay the same. Now, if I'm turning everything into a fraction, remember my 4 is going to be 4/1. To take a whole number and to turn it into a fraction, I put it over 1. My division sign becomes a multiplication sign. I make the reciprocal of the divisor. The reciprocal of 4/1 is 1/4. Well, then I think about cross-checking, and I'm looking at a 25 and a 1, thinking, well, there's no number besides 1 and 25 that can, no number besides 1 that can go into both 1 and 25. When I think of 4 and 12, I'm thinking, well, they could both be divisible by 2, but as we mentioned yesterday, we always want to use the biggest possible number, and the biggest number that can go into both 4 and 12 is 4. So I'm going to think, well, 4 divided by 4, that's 1. 12 divided by 4, that's 3. And so now I'm ready to go ahead and multiply. 3 times 1 is 3. 25 times 1 is 25. I get 3/25. Since I made these numbers as small as I could, I can be confident that's in simplest form. Always good to double check. But when I think about 3 and 25, the only number that can go into both 3 and 25 evenly is 1. So I can be confident that that is in simplest form. All right, tomorrow we'll be incorporating in mixed numbers, 6th grade. Talk to you later. Bye.